Thank you, Annie. I appreciate that. Welcome everybody. It looks like we have quite a few participants, which is great. I do want to mention before I get going that we have two special guest speakers today, Thomas Wang and Shayna Solis. I'm sorry they didn't make it onto the agenda, but I'm very happy they were able to join us for this session. So I'm going to give a brief view of OGC, who we are, and then what we're doing kind of within the open science domain, and then turn it over to Thomas and then Shayna, and then we'll have a Q&A period. However, please feel free to ask questions as we go along. This is, about communication. So please speak up if the moment strikes you. So let me see our agenda. So I'm going to start with this brief movie, if I can get it to play. Can everybody see that?
Is there audio with the video, Marge?
There is, but it's really just music. Can you not hear the music?
Oh, okay. We can't. You have to click the button, so don't worry about it. We'll just enjoy watching it.
Okay. Okay. Uh-oh. Good. So I just wanted to mention that that OGC has been working in the domain of geospatial standards and interoperability for 28 years. However, in the past decade, I would say that the focus and interest on making sure that all of our spatial data and related data related to spatial information has become, the need for it to become open and interoperable is greater and greater with the climate and related disaster issues that we're all experiencing. So we see this as kind of the challenge of our time, is making sure that that we're moving forward and advancing as rapidly as possible the capabilities to ensure that geospatial data is open as much as can be and is interoperable as much as can be. So along those lines has been discussed many times within ESIP is the fact that we continually have more data, advancing technologies, innovation within this arena as well. But back to the, to the data aspect, the amount of data that we're gathering now, the amount that we're going to be gathering in the future, and the fact that this is not just a US government gathering lots of data. This is now commercial industry, academia is very involved. It's very international. More and more nations are putting up sensors, in situ sensors, flying CubeSats and small sats, and having airborne campaigns. So there really is an immense volume and variety of data. And at the same time, we're in what many are referring to as this fourth industrial revolution of technology advancement, with great changes happening. So we have great opportunities. At the same time, we have big challenges that we're facing as well. So again, OGC has been doing this for 28 years. We are a collaborative membership organization. We have over 550 members, actually getting close to 600 members now internationally, all across the globe. Our mission is to make location information findable, accessible, interoperable, and reusable, the FAIR principle. And our approach to doing that is through our membership organization and collaborative opportunities. OGC has, as I said, was kind of the experts in data integration with our members and partners. We're not doing this on our own by any means. We've been dealing with data and time and space for a long time, and are happy to state that we have been successful in creating solutions within this arena, again, with our members, with this collaborative environment that we work in. So this is just kind of a subset of our many members. There are a few, for example, NASA, who has been a member of OGC since its inception, USGS. There are a number of others, federal government agencies, but we also have, as I said, we have commercial industry, Amazon and Google, and a number of other commercial industries at large, but also small. We have startup companies, a lot of startup companies that are joining, and academic institutions as well. So again, this is this is international. It's across the globe. So we have members in Singapore and Australia and all across Europe. And so it's a very, very collaborative environment. Again, we work towards the within this concept of advancing and applying science and technology, driving the integration and the collective problem solving. The mission is met through the FAIR process and commitment to the findable, accessible, interoperable, and reusable. And the standards, the APIs, the workflows, all of it that's developed within OGC are open standards, or best practices, proof of concepts, but they're all open. So OGC is not concerned with, for example, commercial industry. They have their data or develop their services or tools. And we're not really concerned with the interfaces per se. We're in that middleware arena where we're looking to create solutions for open standards that anybody can use, so they're not too expensive for certainly developing nations or small businesses or anything, and that really create a open science and interoperable solution. So, so yeah, we have this, kind of heterogeneous data and processes, and need to integrate a variety of data. As I said, huge amounts of data. The data processing modeling is another area of that we need to do, create interoperable solutions for. Results need to be reliable and described and readily communicated to the user, so that they can then apply them. So Iliad is and actually Thomas might speak more to this, but this is an example we like to use of kind of the developing capabilities within open science, and in platforms that are coming together, integrating services, tools, data, models, and you can plug in your capabilities or unplug them as desired. So this kind of gets to this open science. This particular project really speaks to the open science concept of what we're all working towards. Data integration as routine is what we're trying to get to. There are still lots of inhibitors. We have, a variety of assets that are gathered in different ways, stored in, they have different formats, stored in different ways, different languages. We have first responders and stuff that need access, but they have tools and semantics and stuff that are not necessarily used across the entire spectrum. The size of data, again, there have been a lot of questions recently about data lakes, for example. Do we put all of, does any one organization put all of their data in one place, or do they spread it around? The concept of, not moving your data and instead doing processing and modeling and stuff where your data sits. But then there's the data gravity problem of if you have so much data and it's not movable, there's latency and things like that. Security is certainly a big area in which we're spending more and more time focusing on not just the provenance, reliability, but also protection of private information, health, private health information, or just protection of somebody's data stores, who's allowed in and access to them and who isn't, and when can you turn authorizations on and off and all of that. And then, of course, costs are always a concern. Again, this is one of the reasons OGC works towards developing open standards, but that does not remove the costs altogether, especially for disadvantaged and developing nations. So this is the ideal, of course, working towards a geared system where our business processes and our data and our policies and our models and everything work smoothly together. However, what we really still have is, almost fatter stovepipes. We're certainly moving quickly towards better interoperability, but we still have a lot of long way to go and a lot of work to do to really reach our open science goals as a whole. So within OGC, we are, as I said, we're working on developing best practices and open standards, everything. We're also just this year, with the great support of NASA and their open science program, actually, we'll be developing an open science persistent demonstrator with our members, in which we create this persistent open science capability where anybody that's a member, and hopefully eventually maybe non-members, can come in and contribute tools and data and infrastructure capabilities, test them prior to going operational on their own platforms or with their own systems, so that they'll have this persistent demonstrator will be a system that they can test against this international consortium we have of all these different organizations and their own tools and capabilities and platforms. So through the persistent demonstrator, you can really get a feel for creating open science capabilities within your own operational tools and services prior to going operational. We OGC would facilitate the participation of the science community, the engineering community, end users. We have a disasters working group and a climate domain working group that both have end users from around the globe involved. So these are areas in which we can bring individuals and organizations to the practice of developing and working within this persistent demonstrator. Again, OGC is, as I mentioned before, kind of in this middle area of knowledge exchange and resource exchange, trying to ensure that there is consistent and reliable development of the APIs and workflows and best practices, and ultimately the standards for interoperability, integration, and working towards meeting the open science concept. So this is reusability is one of the aspects of meeting the open science concept. We need to be able to reuse not only the capabilities, but you know, our models. We need to be able to take products from one model and insert them in another model, and do this somewhat seamlessly through standards that we're all committed to and working with. Fair action, again, I've mentioned this a couple times now. When you have just data, a service, and your metadata and specifications, things are fairly simple and obvious. But when we start adding lots of different data sources and processing capabilities and metadata and semantics and stuff, it becomes far more complicated and necessary to kind of commit to collaborative concepts and working together to develop the standards and capabilities to make all of this again interoperable, and making sure that we're still after when I first started in this arena, I'm going to say 20 years ago or so, metadata and semantics, finding data, finding services, finding tools, and having them accessible was it was very time consuming for everybody. And we're still kind of there. There's still, difficulty in the finding and accessing, let alone the interoperability and reuse of the FAIR process. So again, this just kind of quickly shows the OGC path of exploiting technology and services and components for the use in advancing knowledge and capabilities, but doing that through standards that we're all using, pilot activities, community building, and as I mentioned, this persistent demonstrator that we're going to be standing up this year and will remain in place for some time. And then I just wanted to mention some of the organizational areas within OGC, the project areas in which we do these projects. We have Earth observation, climate resilience, domain working group, an analysis ready data standards working group. That's what the SWG is. Data Cube standards working group, metadata, domain working group, marine, federated. We've got a large project with the Federated Marine, developing spatial data infrastructures within that domain working group, geosemantics. So, and these are just a few of them. This is, what OGC does is get sponsors to sponsor work that is identified as a need within the community. And then we put out a call for participation. Anybody, it's open. The call for participation is open, so anybody can submit a proposal to participate in our pilot projects, our test beds within these arenas, and work on developing the interoperable capabilities with people, other members of the OGC from around the globe. And I believe, yep. So that's my last slide. I know I went through it rather quickly, but if anybody has any questions, I'm happy to take them now, or you can hold them until after the presentations. We'll have plenty of time then to have Q&A as well.
Great, Marge. There is one question that is in the chat. This is, it says, do you incorporate chemical facility data as increased extreme weather will lead to more chemical disasters? So can you kind of speak to OGC, and this is a common question that ESIP gets as well, related to working with data facilities compared to actually being a entity that hosts and is a data facility itself?
Yeah. So the short answer is yes. The longer answer is kind of. So we just worked on wrapped up a disaster pilot in which we were working with some end users who the concentration was on wildland fire. And so it's not just the fuel of the fire and where it's spreading, and the atmospheric and weather changes over and around the fire, and resources for water or airborne missions to help put the fire out. But it is also a question of what are the facilities, communities, or to your question, the chemical facilities that could be affected, for example, by a fire. In this use case we were working in was fire. It could be flood or anything else, but so yeah, we try to bring in any end user or organization that would have data or some type of feed into the overall need to be able to get access to data and make it interoperable so that the first responders can be aware of the risks and work on mitigation or prevention or whatever. And so if there's a chemical holding facility or something like that in the path of a wildfire, then that would certainly be very important to the end user. So it's very important data that would need to be gathered and made accessible to them. So it would certainly something that we would look at and try and get anybody that had those data sources and maybe even the facility themselves involved in a use case. Does that answer the question?
Yes, thank you. Well, one more, is there a way, so I know there's TRI data, but that's often, I mean, it's not often, it does come from industry, and people who used to work in the industry, they'll tell you like how you can get around reporting. And like, we know that if there's a hurricane, they're not gonna report what they're releasing during the hurricane. So is there a way for like community data or other independent data to get to you?
Well, yeah, we OGC are happy to accept any data we can get our hands on during our pilot project and testbed projects. So, but I will say that we go through our sponsors and our participants to get access to that data. So we really rely on the people participating in these working groups to get the data that's necessary. Now we can, if we're missing something, we OGC do our best to send out feelers and try and pull people into the projects that might not be there, that might have a service tool or data or something that's needed to really enhance the project. So, but we are, we are limited as others are to what people will share.
Thank you.
Yep.
And thanks for that additional resource that you added, Steve. We appreciate that. Let's see, should we, is Tom?
Yes. So do I need to unshare, Annie, or can you grab it from me?
Yeah, I will grab that from you and I can pass it over to Thomas.
Okay.
Thomas, you should be able to, perfect, on top of it. All right, awesome.
Can you see my screen or slide?
Yeah,
Yes.
that looks great.
Awesome. All right, so I'm gonna try to talk fast. So my name is Thomas. Thank you for having me, Marge. I would like to think myself as a mystery guest. That's why we're not on the list, right? So, so today I'm going to talk about federated digital twins. So this is going to be a plenary this Thursday as well. But this what has been focusing on is definitely a hot topic. Let me click here. So just give you a quick intro myself. Very much like March, I've been around for a long time. So been working with all these mission career. I also manage large staff software engineer focusing on product generation and data management, access, and everything, including data science. So, so today I'm going to talk about the Earth System Digital Twin. So, sure, those of you who've been to previous ESIP meetings and some of the previous AGU event, you'll hear about the Earth System Digital Twins, which is something that the NASA, the AST program, been investing for the last year or two. I have the privilege to manage two of those projects. And the goal for Earth Digital Twin, I just have to have three primary goals, right? So the term digital twin being used a lot, and I would like to think of it as more like lots of people have used the same term, but they might be slightly different. And this is why event like ESIP is so important, is try to bring in the collective knowledge and view and work together and see, at the end, what the community think what digital twins ought to do, right? But for AST, they have very specific goals. There are three goals, right? One is being able to continue to provide continually accurate representation of the system that require actively onboarding the latest observation, value-added products, and be able to take advantage of things like advanced data analysis and artificial intelligence, any state-of-art numerical modeling, all that bring together so that we can develop tools to conduct things like what-if questions. Like, what if you have this certain amount of rainfall in this region? What if you have this wildfire happen here in this part of the California? What the air quality is going to look like? Those are what-if questions are extremely important to help us to prepare and look ahead, and also think about potential mitigation options. So I would think about what if is not just a simulation, it's more about empowering actionable prediction, things that you can act on, things that you can do. Decision maker might be thinking about relocate the exits or changing some shipping schedules or moving some of the facility around. For mission planner, they might think about being able to dispatch additional observation or any instruments orbiting the area of interest. So the project that we're building is called the Integrated Digital Earth Analysis System, called IDEAS. It's really a framework, and I'm a computer scientist, so I don't like to build one-off solution. Means here's a cool app, that's for air quality, and that's one-off solution. I don't like that, right? I want to build solutions that actually reusable over time, extensible. Some of the software I developed for Mars Pathfinder is still being used today for that very good reason. So, and you know, Pathfinder was launched in 1997. So tell you how long I've been doing this, right? So the idea behind IDEAS is creating a framework rather than one-off solution. And the goal is to creating bridges rather than try to say, hey, why don't you move everything to HPC environment or everything to the cloud? I think those are great ideas, but they just require a lot of time and testing. Instead, building bridges, connecting mature solutions, having the data next to the computations, so that you don't have to move the data around all the time, right? So the right side is really the illustration. What I see a digital twin is like the blue area is the physical environment, and the yellow area is the digital environment. You have each of these boxes represent functions. Okay, you have the communication, which is provide data access, like the DAX. You have aggregating data to some kind of environment, like could be a cloud environment or could be HPC, where you can do value-added analysis that or transform the data into a harmonized format that could be fit into numerical models or machine learning AI models that enable us to do forecasting predictions. That forecasted prediction help us decide, do we need to do additional accuracy, data acquisitions? Do we have any mitigation plan if we know this is about to happen? If this is acquire additional data, this could be, you know, let's say dispatch a drone or go to some in situ sensor pulling additional data over, and then have the data available. And again, this is a continuous integrations. And I love this picture because I kind of stole this picture from the last ESIP meeting because we were at the City of Bridges, right? So, so this idea about big data, right? In those of you who's been known me for a long time, I've been working with cloud for a long time. You know, I'm always interested in trying to find out great solution for building a solution that enable us to quickly work with large amount of data. But over the years, you start realizing that putting all the data in one platform is just not feasible. It's just too expensive. Well, it's great software engineering experiment, but the reality is you just have way too much data. The right way to approach big data is really creating a community of services, right? So over the years, we've been building open source solution. These little boxes all around, these are actually same open source software, same framework that we developed, but they deploy for different disciplines. They use the same common APIs, user right in the middle can use Jupyter Notebooks, or could be using things like a GIS application, could be using IBL or MATLAB or even Fortran. Talk to these services, and the computation or analysis is done right next to the data. So there's no massive amount of data movement there, right? But the glue is the interfaces, the standards, the APIs, right? The information model. So the another part is that each of these services is actually funded by specific sponsors. So I don't have to copy the data again. I don't have to pay for the storage myself just so I can do the analysis. Sea Level Portal is being paid for by NASA. Grace Follow-On is paid by NASA as well, right? And you have Echo, you have a community supporting this, right? So these are just some examples where you can tap into these services using just common API. And some of the charts right here on the right side is essentially created by one of the scientists I work with, who was able to just leverage the comparing, let's say, the Echo data with the measures data that's actually sitting at the Sea Level Portal without having to copy the data across the wire. Okay, so the vision of digital twin, again, just to reiterate, is really try to create this connected environment that connects data access, analysis, large numerical models, AI or data science. And for the NASA team here, right, all the NASA audience here, these actually connect to at least 3 or 4 different NASA programs. And unfortunately, most of the NASA programs, they have their own objective, right? But creating this digital twins, you're sort of connecting all these different investments together, and you'll find out, are there actually gaps in our investment, right? So this is this opportunity here to really put all these different program investment into the works. So the current development that we're doing for IDEA is actually led by JPL. I'm the PI for this work. We are collaborating with Goddard and also Langley. That's what again, NASA wants us to make sure we're start with more than one center, so it's not just dominated by one organization. The goal is creating encapsulation APIs, right? Information model, common APIs, being able to take advantage of multi-computing, so it could mix up between HPC and cloud, IoT. It needs to be distributed, so it's not to be co-located in one big locations. So for the hydrology or using flood, we are actually using a river discharge model was built by JPL, but we're also connecting with LIS, which is running at the NCCS at Goddard. And the data is actually, some of the data actually served to the Langley's Powers project. And then we deploy a bunch of ML capability to the cloud do SageMaker. And you see these are different assets actually based on the situations, right? We might be dispatching a drone or satellite or value-added processing to generate additional high-quality products. We are partnering with CANES, so this is definitely an international effort. So it's a NASA working with the Space for Climate Observatory project. They funded a project called Flood Dam. You probably might heard of it. So we are having regular interaction with them. We are building common interface between the systems. They also have their own sets of models. They have own sets of machine learning capability, and they also have commercial data that actually have to do with infrastructures, human populations and all that. So one of the things that we've been so far, this is something that we piloted on the last month at AGU. So we were able to bring in run these models, land surface, think about rainfall or floods, right? What's going to cause flood? Well, massive rainfall, surface runoff, subsurface runoff, discharge to the river, right? Then you can change the water level and you have the flood risk, right? This is all interconnected, but these systems are running in different environments. They actually have different expertise. And we were able to demonstrate some of this capability for the Mississippi River, the Gorham River. And one thing we added to this work is to VR, right? So I see VR is actually a great add-on to digital twins. Think about being able to run scenario-based simulations, interactively do an immersive environment, but it's powered by the same platform that you can talk to using Jupyter Notebook or your GIS apps, right? And we are able to generate, things like, visualization on demand. So The other application that we've been building for digital twins is for air quality. This is work that we've been partnering with several organizations, and particularly also with the city of Los Angeles. And the goal is to try to figure out is what impacts, or what are the composition, what goes into the airs. And especially where I'm living in California, we're sort of like a wildfire country here. If there's a wildfire happening, all right, where is the what the chemical the composition go into the air? Who are the people who are most sensitive to? All right, we need to be able to predict that. So we established a platform. This is working with Phil Yang and his team at the George Mason University. Right, we created a distributed architecture, a single interface, but this huge distributed system. User talk to our system using Jupyter Notebook or GIS app, but we are sharing data and analysis between the two environments. If you know, JPL is actually sitting in Pasadena, West Coast, and GMU is over at Virginia, and they also talking to HPC, but the user won't have to care about that. Right, they're just using same API, same information model, and they're able to compare and visualize the data. So we have some product do this air quality project, and this is on demand. These are on the fly, on demand analysis that we can serve up the things like the PM 2.5. This is actually an example from the car fire in California a couple of years ago. That you can analyze the different species and you can compare them and see how they interact with one another. This one thing that was really cool we added was we added sensors on top of one of the JPL building. This is actually the building my boss lives in, so they care about their air, right? So we pulling things like black carbons, PM 2.5, right up where JPL is. So it's kind of interesting. We just have July 4th when they have fireworks. Right next to JPL is where Rose Bowl is, and we pick up all the black carbon measurements on live, right? And we were able to get that into our system interactively. So again, the whole platform that we're building using all common API, you can actually use Jupyter Notebook, but you can also build fancy apps like this, and you can use run the app on your phone without having to replicate all the data into one location. What's going next is we are building on science-driven observations. So wouldn't it be cool to be able to predict what might happen, what could happen, the likelihood, and can we dispatch any of the orbital satellite to focus on those regions? So we'll be, in this year, we'll be focusing on, can we use ML and analysis to predict and also retest the upcoming mission to Maya, and some of you, I'm sure you're aware of this. The camera is retastable, right? Can we simulate the retasking of that to demonstrate that it is possible to be able to use science to drive the next observation? Again, those of you who know me, right? I've been preaching this many times. Big data is about being smarter about data. It's not about how big of a cloud you can build or how big of HPC you can build. Right? It's all about being smarter about what data to bring in. You cannot put all the data in one place. You just can't. You just can't afford it. Okay, but you need to be smarter about deciding what data to bring in at what time and for how long. And porting everything to the cloud is not a good way to do it. I mean, eventually you might want to, but use the software where it's mature and connect the bridge, right? So our goal is focus on agility. It means being able to dynamically figure out what situation and what data is needed and relevance, what's necessary, and don't try to bring everything in. And need to come up with a solution that's sustainable, right? It means that sustainable in terms of the software maintenance, sustainable in terms of operation. Can I afford this thing? We all can try to put like large scale model from HPC to the cloud, but can you afford to run it? It's too doggone expensive, right? So those are the key things that we want to focus on. Again, those of you who knows me, I've been doing open source for north of 2 decades. And so we open source everything that we do. We are a team of doing professional open source. We share our recipes. Our Apache SDAP project will be graduating this year. So be a top level Apache Foundation project. We have a project management team that actually not just on JPL or on NASA, this is actually across the globe. We also host seminars, like event like this at ESIP, that's actually, this is from ESIP. 1 year it was packed, not enough chairs. So again, in conclusion, big data is about being smart about data, right? We need to be able to deliver reusable software solutions. You need to build a community, a framework that actually embrace and support by community. I'm not here to build islands. Just too many islands out there. We should come up with common solutions so the community can support this, can keep this moving, right? I don't want to own everything myself because I'll have other things to work on. I have a large team to manage. So the other part is we are actively engaging the global community. So we working with like group like this in ESIP. We working with March and OGC, the CIOs and the UN and GEOs, and the goal is again we want the community to help us define and shape the standard, right? What the API looks like. And again, I'm glad that we have OGC on board we can have a chance to work with them over this year to start defining what the Earth System standard should look like. And this is really exciting time for me. So, okay, watch for Thursday. It's gonna be really exciting. You guys see me again, but I'm just gonna be sitting in the back and with Phil. And we are going to be having EGU. If you come to EGU, we have a couple of digital twin session and also IGARs. All right. If you have any questions, feel free to reach out to me. Thank you so much.
Thanks, Thomas. That was great. And there are a couple questions in the chat if you want to address those while we pass it over to Shayna.
Okay. Phil, you cannot ask questions.
All right, Shayna, we can see you. Do you want to go ahead? And Marge told me there will be a bit of a discussion at the end of all the speakers. So Phil, you can answer questions in the chat, or we could have that as a group discussion after Shayna's presentation. So Shayna, we could see you and see your slides.
Okay, great. So you want me to go ahead and you're gonna have Thomas answer his questions after?
Marge, what do you think?
Yeah, Phil, can you wait for after Shayna's and hold
yeah, that's fine. That's fine.
Or just slap me.
We'll find you.
All right. Well, hopefully
Hi,
I'll
Shayna,
wrap it up quickly as your second special guest. Thanks, Marge. This is like the Muppet Show, right? With a special guest. So I'm Shayna Solis, and I'm the co-founder of Navteca. I wear a lot of different hats. I'm also a NASA PI in the wildfire program. And Marge invited me to kind of connect the dots for everybody about how open science really feeds into the emerging technology areas that we work at with Navteca. So hopefully this will give you some tangible examples of the importance of open science and all of the things that OGC and ESIP and all of the different member organizations are working on, and how, when we make that data and information open and accessible, how it can really drive innovation. So I've been an active member of ESIP for quite a while, AGU. I'm sure some of you have seen some of the different demonstrations that we've done before. If you haven't, I'm going to give a couple of examples here. And then hopefully we'll be together in person in the summer. So one of the important things, with making the data available is that it becomes understandable and actionable. It's great within the science and research community, but really at the end of the day, there's so many end users that make critical decisions based on the information that is put out there. So one of the things that we really think about a lot is how do we take that data the last mile? How do we really put it into a format that becomes relevant for these end user communities? I'll give you some examples of that. So one of the areas that Navteca has been investigating for a number of years is immersive data visualization. This can use virtual and augmented reality, but really it's about the underlying game engine. It gives us essentially limitless modeling capabilities for that enhanced real-time rendering. So we can really connect the dots between multidisciplinary data sets. So I want to give you some visual examples of what that looks like. When we ingest data in real time, especially when there's APIs for existing portals and applications, then again, we can really bring that data and information into a visual framework that can help people from many different stakeholder backgrounds understand the information that's being presented to them. So through a collaboration with NASA's Disaster Applications Program through the Science Mission Directorate, a project that we did was actually connecting their ArcGIS online portal to virtual reality. And we were able to show basically in real time data for the Ridgecrest earthquake a couple of years ago at the Esri User Conference. It was literally 2 days after it occurred. No additional coding was necessary to actually show people that data in a virtual reality headset at the conference. It was really exciting. So let me give you an example with a video of what that looks like. When we take a NASA data product, such as the Global Landslide Nowcast, we can put it into this virtual environment in a way that now becomes understandable. We combine it with geospatial backgrounds. We can bring the real 3D terrain, 3D building models, all kinds of different other information about population, about critical infrastructure, roads and bridges, utilities. And so now this data can really come to life. This data set is critical for some of these areas. So it's important that people have access to it, but also that it's available in a way that you can build off of it. I know many of you already know that, but I wanted to give you this tangible example of how we use this actually in a pilot project with Guatemala City, and brought this information not just to their attention that this is a data set that updates every 3 hours, showing them real-time landslide risk, but that they can actually bring it into a geospatial platform in a way that people like civil engineers and emergency managers could understand, when maybe it would be more difficult to understand just from the geospatial portal itself. When we put these types of information and data sets into the hands of those end users, then we can really help them improve their readiness and resilience, which at the end of the day is really everybody's common mission. So just sort of driving that home, all of these partner organizations that have data, you sort it, you arrange it, you produce wonderful, products with it, we can tell a story with it. So when it's open and accessible, we can put it all together in a way that can make it more understandable for those end user communities. So here's another example of that with a video. This data set is coming from NOAA's SLOSH model for sea level rise. So this is information that's publicly available on a web portal. And because they have an API and it's openly accessible to us, we are actually able to bring it in to our virtual environment, layered on top of 3D buildings and 3D terrain. And then you're seeing virtual reality controllers here, be able to show you what that looks like with an actual water texture. So instead of just seeing it as, a map where maybe it's difficult to understand what is the sea level risk for a specific street, even for a specific building within the context of that neighborhood, we can bring this information to life for people in a way that maybe just the data itself in a more raw format wouldn't be able to be incorporated as easily into a decision-making workflow. Another example of that comes from the work that we did with Guatemala City. They had a multi-hazard risk analysis done. It was a very dense document that was difficult for the decision makers to understand. So by bringing that data, there were lots of maps, seismic information, and things that were, again, not necessarily easy to incorporate into emergency management plans or into, decision-making for civil infrastructure. By turning that into an interactive visualization, we were able to really bring this information to life for them. So the yellow lines here are fault lines, and you're seeing sort of a fly into the international airport. This is also interesting, and I think a good example of how you can bring multidisciplinary information together. So it's not just the science information, it's what else is out there. the white 3D building models that you're seeing here, it came to light that a different department within the city government had these 3D models for property tax purposes. So the emergency information and geospatial team didn't even know that they existed. It came to light through our planning sessions for this project. And so we were able to incorporate them into this visualization. So it's an example, you know, of how when the information is siloed and nobody knows that it exists, you know, that when we can make it more easy to find things, even if it's something that didn't occur to you that could be relevant, when we can bring that all together, we can create a very nuanced tool that could enhance, in this case, the decision-making for disaster readiness and increasing resiliency for that region. In fact, they were able to use our visualizations for an earthquake simulation drill that took place in Guatemala City last February. So you can see that this was part of the situational awareness briefings in the Emergency Operations Center. So it's very exciting to see, again, how when the data is open and accessible and we can put it into a format that makes it easily understandable, then being able to see it in that end user setting was really exciting for all the different stakeholder groups that were involved in the pilot project. I want to move on to a different area of technology that we work with that, again, I think is a tangible example of how, you know, the types of standards that OGC develops and ESIP, you know, when we make that information available, we can foster different technologies such as natural language processing. So when we use conversational AI, if the information is accessible, if we can get to it via API, if we can find it, then we can improve knowledge discovery. We can really help foster that collaboration between scientists, stakeholders, and even the public. That's the goal of that knowledge set. And this really ties into many of the open science goals for accessibility and accessibility. So some of the DEIA goals, removing those barriers to access, not needing to know who to ask. This can be improved through that conversational AI. Because at the end of the day, people just want answers to their questions, whether that's a question about a data set, how to find something, or a question that is more tied into decision-making itself. So because it's in an NLP session, I'll skip a little bit of this, but you know, when we search with NLP, it is quite different than with metadata tags. So again, when following the FAIR data standards, we can really enable these types of artificial intelligence technologies in a way that isn't possible if you don't follow the standards. And the results that people are seeing are very exciting. You know, the openly accessible data and information can help accelerate R&D, can increase people's productivity within teams, and improve their interactions, both internally and externally. So, you know, when we think about open science as also being open access to information, you can see how it really can then feed into innovation and accelerating everybody's missions. Some additional open science initiatives that we've been working on are projects, some of these through NASA, through our work with the Science Managed Cloud, this API Baker. So we're working on open source Jupyter Lab extensions, Dask Hub, and then other technology tools for improving data accessibility. I know our time's limited, so I don't want to go too much into these, but if you're interested in these particular projects, please reach out and I'll definitely put you in touch with those team leads. So just sort of to leave you with this idea of, you know, when we put this all together, the open data, geospatial, you know, immersive technologies, natural language, and what else? What else can we add to this? Because really the open science initiatives, you know, leave these blanks to be filled in. And that's what's really exciting right now, is that you can bring, you know, lots of different information, multidisciplinary information together in a way that really is unprecedented. So I want to show you some of our current work that's being funded through the NASA Wildfire Initiative through their Applied Science program. And what does that mean? So right now we are looking at interactive frameworks for wildfires. And this is an example of, you know, using the game engine immersive technology interface. We're also adding in a natural language processing layer so that when it's ready to show you all, you'll be able to actually get contextual information by asking a question, about what am I looking at? Where did this data come from? And get a natural language response that's all data driven, all based on, where you located geospatially within this particular visualization. So here you can see another example of that, showing, what type of trees am I looking at? What is the fuel for this particular fire? What date did these hotspots occur? We can bring all of the cinematography of the game engine. So being able to see, night to day, or how a smoke plume obscures the sun. This can really make this data much more understandable to people from across many different spectrums and backgrounds. So it's not just the science and research community, of course. There's also state and local government. There's many different, stakeholder groups, from the public utilities, from the emergency response sectors, fire, police, and of course the general public, being able to understand and hopefully prepare for future events as well. So one more video of that. So again, all of this can be based on, is based on real information. Point clouds for those smoke plumes get translated into something that's very realistic. The hotspots for the fires, being able to bring in the wind vectors, environmental conditions, all of the geospatial details and the terrain. And then of course, once we add in the NLP, you'll be able to ask questions and get a contextual answer about what you're looking at. So basically having that virtual assistant looking over your shoulder to help you understand and interpret the scientific information that you're looking at, the sources of data, maybe providing you links of where you can find more, access the raw data itself. So that's kind of our current project with this. And I think gives you a taste of what the future holds and how all of this comes together through the open science initiatives. So here's my contact information. Please feel free to reach out. I'm also in the NASA system. I should have included my NASA email here, and hopefully that gives you a little bit of an overview and also some time for questions and discussion. Thank you.
So thank you to both of our mystery guests, Shayna and Thomas. So Annie, are you going to read the questions, or how do you want to handle this?
Well, let's see. We have, oh, there we go. We have the questions that Peter and Phil added earlier for Thomas, and I would just ask anyone else on that is on the call if you'd like to go ahead and add any questions you have to chat, or I'd encourage you to let's see, I'm going to go into gallery mode on my Zoom. And if you'd like to turn your camera on and just engage in an open discussion, we can also do that. So maybe we could start off with Thomas, if you could address the questions that Phil posed. And then if anyone else wants to add a question to chat or raise your hand, we could just go forward like that.
Yeah, and actually the question is actually me and March. So March, you have to take a piece of that too.
Right.
So, so we don't have the official and direct mapping yet at this point, but I'm sure the things that we what we see for digital twin is opportunity for this community. There's a lot of standards that's already available. OGC certainly has a lot that we actually I'm currently leveraging things like WMS, WMTS. These are common standards. So digital twins, what we're looking for is what are some of the standards we can leverage? What are gaps what work that we still need, right? I mean, things that we identified at the NASA digital twin workshop a couple of months ago was there's things that we still don't have, like things like, do we have standard how to communicate analysis, which is something that I have been working on with things like Apache SStack for many years. Those little orange boxes you saw earlier, I'm sort of creating my own standard, but it's just me and my engineer, right? But this is why I'm here, right? Working with the community here is like, well, it works for me with my small little world. but may not work for across the board, right? So I think there's a lot of opportunity there. What I don't want us to do is just create something just out of thin air, but more looking at what is there. What can we use first, and then what is missing, and can we augment something? I mean, there's some of the OGC standard that I see is very close, similar to digital twin, but not exactly. Can we use that as a base, right? So that's something I would like to look at. For Peter, yes, there's some APIs. We have some documentation of some of the functionality API that we are releasing to the Apache Foundation, but there's not complete set for digital twin API yet. We are releasing a digital twin notebooks that is actually shared with the French. If you ever work with the Europeans, right, they don't want your software. It's like, no, just tell me what API do you want us to use, and then they would go build their own thing, right? Because we got everything running on Amazon, and they go, we don't like Amazon, So just give me the API. What's the specification? So we've been maintaining a notebook with between us and the French, so that they can see, oh, this is how you work with our system at the NASA level, and then they can start working on how to integrate with our system. So that's my way of working with our international team here. So yes, some documentation, but not fully documented yet. So March.
So, yeah, Phil, there is not I would say there's definitely not a mapping of standards, especially for digital twins at this point. I think, as Thomas was saying, everybody's still kind of figuring out, how to make these connections and stuff, and how to put the digital twins together. And there's such a variety. However, again, as Thomas mentioned, one of the things that we're discovering within OGC is that just many of the standards that have already been developed, OGCs and others, can be applied, or they might need some slight adaptation. And so we're working on that within different pilot projects and test beds at OGC. But there are actually a lot of capabilities that have already been developed that can be applied to create these systems. So I think, the mapping will come when we're further down the path and better understand, everybody comes to a common understanding of, or some level of common understanding of what a digital twin is, because there's great variety even just in the description or identification of what a digital twin is. So I'd say it's coming, but yeah, it's going to be the community that creates that mapping, and with standards that already develop, and then new standards that are where the gaps are, or adapted standards that can be applied but need some adaptation. And then for OGC, the documentation for various APIs is available for those that have been made public. It's you can go to the OGC site, and you can look up under the standards or APIs for the documentation of what they are, how to apply them. If you need help, you can contact OGC. There's a kind of a general OGC email address, or you can contact anybody within OGC. Any of us can help with identifying, if you're looking for a specific capability, a specific type of API or something, or you found what you need, but you're not sure how to implement it, we can always help.
Yeah, to add to that, right? I think the in addition to provide documentation, I think it's important to provide recipes or working notebooks. I found that that's actually most of the engineers that I work with, they don't read. They want to download the software and run it, right? Now I know Jupyter Notebook is great, but also it's not portable. I haven't got a portable Jupyter Notebook running at all. I mentioned this at AGU. So proper documentation in terms of running that notebook is important in terms of what are the dependencies that. So that's when we deploy giving our notebook to the French as a education, as a recipe. We also document, like, we tested this in this platform. Here's the library that you need to run it. So I encourage the communities also do that when you sharing any recipe. But again, documentation is great, but since these are technical interfaces, it would be great to even have working examples. One thing that I encourage March to look at is maybe OGC should also think about some kind of a baseline, unit test, right? To say, here's a test that's certified. We say you have a WMTS interface. So, okay, well, let me run this little, hello world WMTS client and see if does it work, right? So I think I hope to see some of that too, and do the digital twin effort. So.
Yeah, and we do have compliance testing for, some of the basic standards and stuff, but not yet within the digital twin domain.
Peter. Did we just scare him away?
So. I can't see everybody, so if somebody has their hand up, I might not be able to see it, so.
Peter, could you throw your question into the chat since your mic isn't working?
Any other questions while Peter fixing his computer?
I just cycled through everybody. I don't see anybody else's hand up.
Yeah.
Hi, Much. This is Phil again. I do have a question for Shayna. It's great presentation and great visualizations. I know that looks like you are integrating data sets from different sources, like the fire simulation, the tree simulation. Do you pull data sets from other sources, and what kind of API or standards are you using for interoperating among the data sets and the systems?
Yeah, thank you. That's a great question. And actually, that's one of the reasons why we decided that having that natural language processing component was really important, because it gives you an interactive way to actually query the visualization itself and say, what is this information and where is it coming from? Because, a lot of times when a visualization is presented, you don't have that. It's just, it's given to you, and you're sort of with the mentality that, well, here, I'm showing it to you, so this is real. But with science, you need to be able to show your work. And so this is, hopefully an innovative approach to doing that, to saying, this is where the information came from. Here's the source. Here's where you can access the API yourself, so that hopefully it also becomes something that's recreatable. So it's not like, Thomas was saying, just a one-off, thing, but actually providing you the recipe for creating your own contextual visualization somewhere else. So I've showed you a wildfire, in California, but obviously this is a global problem. And so if we can give you access to, these data sources, so that's kind of coming soon. I hate to give you that answer of like, oh, it's not ready yet, but this is, a current project. So, hopefully either within ESIP or AGU or both, once we're ready to publish the findings of this, that will all be shared and hopefully be very useful for the community as a way to make visualizations more accountable in some ways. Like, where did you get that, and how can I create it myself?
Thank you.
Sure.
So I see Peter's question about API standard and how do we deal with the changes. and needs on standardizing API from data providers. Yeah, so API definitely will change, right? Evolve over time, but it's not something that we want to. This is where this software and system engineering, it works, right? We really want to think hard, right? Think about how we work with as this, Doug Newman here, I point out my good friend here, right? I mean, we spend a lot of time just looking at the data models and the Earth data model over time. It's not something that we just pull out of because Thomas said this is what it is, right? It has to test it. This is why the community is so important to come up with sets of API interfaces that actually work. I wouldn't say 100%, but I would say something that would work at least somewhere in the 80% majority of the cases. As a software professional, I see there's a couple options in the API changes. One, you don't change, you just add more, right? And that's the Java model, right? You never see things deprecated. They just say, it's deprecated. You get this annoying warning, but we still support it. The other one is just throw versions into the APIs. So there are options for that. I'm sure that when we start working closer with OGC, definitely work with some of the experts in terms of how they evolve different versions of their API over the years. So yes, these are good questions. We don't have all the answers yet, but we have definitely have some options.
Yeah, and I to build on what Thomas was saying, there's there are big efforts to standardize, but again, this is kind of a new path in creating these open science environments and working more with APIs than actually developing brittle standards. And so it's an evolving process, but the concept is, yes, at some point we will as communities combine or concentrate on certain APIs and identify them as this is the standard that will be used to do this process. So again, we're working on it. Everybody, I can tell you, everybody from around the globe is interested and working on it also. So the more we can do collaboratively and within communities, the better. The better interoperability and capabilities and stuff we'll have once they're developed and standardized.
Somebody had made a good point about the fact that there really aren't standards for even what is a digital twin. And some of these newer technologies, I think that's part of the problem, is that we don't really have a good definition for, what is the metaverse? What is a digital twin? Some of these things, just the definition itself is still kind of to be TBD.
Yeah. Evolving.
Well, this is why event like this is extremely important, right? Because then we can help with sharing different points of view, and this is why we go into EGU too. So seeing the European, they are doing a lot on the digital twin themselves as well, and start talking to the people in the UK. They also calling digital twin, but they have a very different perspective on it. So I'm going to be meeting with them when I go to EGU. So the point is to come out I think the world itself should be come up with something that actually say when we call it digital twin, or the whole point is that what frustrates me is that you call it digital twin, you're not sure what this other person thinking about, right? So, and then we deal with this with a lot, right? In earth science, the taxonomy, and somebody used the term, a scientist used the term, but you kind of have to localize it to their domain to understand, oh, that's what they mean over there in that domain. So I hope that at least for the digital twin, we can come up with some general common understanding. There might be some specialization. depend on the community or discipline, but definitely something high level that would be helpful in terms of formulating the standards.
It truly would, because we, and a lot of times in working with, especially when we first begin working with some different organizations and stuff, and I would say especially kind of at the end user level, a lot of what people think a digital twin is just a model. And so there's a lot of confusion between, what is and what is not a digital twin, what is and was, where do models end and digital twins begin.
Right.
Right, I don't see any hands up.
What is a question there?
Yep. Shayna, this is for you. Can you see it, or do you want me to read it?
Yeah, I see it. What are your biggest challenges? Steve's gonna hit me with the the existential question at the end of the chat.
That's okay.
I mean, there are enormous challenges, but so one, I guess, is just knowing what's out there, which is part of what OGC is really trying to address through some of these fair standards. Is you start, so we've done a lot of work with different disasters, but this was sort of our first foray into wildfires, and it was like landing on Mars in terms of, now you have to know all kinds of different people and who's working on what and different institutions. And so I think it's just a challenge to have that centralized knowledge in some place, just to be able to quickly figure out, what's out there and who has it. Obviously we're experimenting a little bit with conversational AI as a potential way to bridge that gap. It's not going to be perfect. So that's one challenge. Another is just the speed of evolution as these technologies are, everything's kind of evolving and changing very quickly. We're trying to work as quickly as we can to keep up with it. But more than challenges, I think I'm just excited because it's really, really exciting moment to have these tools, to take a game engine and be able to bring all of your scientific data and information and sort of repackage it into a format where people are going, oh, that's so cool. And they're looking at Earth data or climate data, being able to show this to a politician, and instead of them pushing back about climate change, oh, I didn't know that, because it's now presented to them in a way that's very interactive and engaging. So I think more than a challenge is, for me, just the excitement of the technology and what it's enabling right now.
Yeah, agreed. It is, for us as well, it's very, very exciting, and it's especially energizing to work, within like the OGC environment with the greater community and from across the globe, because it is incredibly energizing when, a test bed comes to the end, or a pilot project or something, and it works, and, there's cheering and, oh my God, we made it work. And, we're, ready to push this to become a standard for anybody and everybody to use. I would say, one of the challenges we have is in, and I think this is across the board, because this is not just a challenge for OGC, but one that I've experienced in, my many facets of my work life, and it is in finding dollars for operational use of all of these developments. It's it's incredibly hard sometimes to get some of these things adopted just as, budgets are tight and so you really need to make, a strong return on investment argument in many cases. And it's, it's not that it's not wanted. It's desperately wanted, but it doesn't mean that it's easy to find some place to park something and the money to keep something operational.
Well, the question wasn't for me. What think was the challenge is just for one person. But I think that but I can share that I just add to what Marge is saying, right? Yeah, we are a nonprofit organization. At least majority of people here are, and we actually have a unique challenge. That's different than the commercial or for-profit organization, right? Everybody knows the cloud actually has has the ability to auto scale. That's great. Well, if you're doing Amazon, you're doing a shopping cart, you can auto scale. If you sell more stuff, auto scale it, right? Then you can make up the difference. Well, for us, we have a fixed budget. Auto scale doesn't give us more money. It just means that we burn more money. So the bar is a little bit higher for the software engineers. For my software engineer, I'm looking at is, well, before you think about spinning up another virtual machine, thinking about solutions that actually can fully leverage or optimize your software to utilize what you already have before you scale out. Things that the commercial sector won't think about too much about because they can make up the difference. So I think the challenge here is to my engineer is to go cheap, right? Think outside the box and be innovative in terms of how to be conservative in terms of the resource. Something they don't teach in school anymore, by the way. I'm teaching school at 9, and it's like, what? You don't even talk about memory management, something 101. So I think the opportunity for this is think about how to make the code more efficiently and optimally running on the cloud. This is why I don't believe in being able to push any random code to run on the cloud and say, call it a success, because it is not efficient. But the other thing that the challenge that we look at is, I think it's more of a culture, right? And the group knows that this is that do not invent here syndrome, where you make something available, put it out there, people don't trust you, but because Thomas put it in there, he looks like, I don't trust him, right? And this is why we work with things like Apache Foundation. So I don't own it. JPL doesn't own it. NASA doesn't own it. It's Apache Foundation. The global community owns it. Now I'm working with OGC, even better. So now it's all based on standard API. Hoping that this is ongoing is about educating and showing that, hey, using this solution may stop you 80%, what get you up there like 80%, right? And that actually is good for you. And you're not depending to have to pay the people who create it. It's actually open source, is available, and it has a community behind it and supporting it actively. That's a huge plus. So I think the culture is a big challenge, and I'm glad to see things like open source, open science making headway here. It's sort of changing the view, and I do hope that it's not just a slogan. I do hope that it will become something that people would start, practicing in their own shop. So.
Well, thanks everyone. Marge, any last words? I want to be respectful of everyone's time, especially those on the East Coast that are now thoroughly after 5:30. But yeah, go ahead and wrap it up, Marge, and then I will say thanks to everyone.
Yeah, time flew. I had no idea it was 5:30. So again, thank you to our two mystery guests, Shayna and Thomas. I appreciate you guys joining my session to present your work and the direction you're going with open science. Thank you to everybody that joined this session. And if you have any further questions, I'm sure that if you can't get a hold of Shayna, Thomas, or myself directly, ESIP certainly is a conduit to all of us. into this larger community. So please feel free to continue to ask questions or get involved after the session ends. Thanks all.
Thank you.
Thank you.
Thanks, Annie.
Thanks, Marge. Great to see everyone. Look forward to seeing everyone for the rest of the week.